Hi, and welcome to my channel if this is your first time here. My name is Pedro, and I've been leading projects in the corporate world for more than 10 years, from waterfall to agile and everything in between. Today, I want to talk about PERT, a very useful tool that when used properly can considerably help a project team deal with uncertainty. We'll explore the theory behind it and then break down how to calculate PERT estimates. The video has section markers in case you want to skip ahead. And remember, this video is also available in Spanish and French on my channel. Without further ado, let's get started. PERT stands for Program Evaluation and Review Technique, and it dates all the way back to the roots of project management. PERT is an estimation tool that uses probabilistic principles to improve the accuracy of estimates over typical averages or best guesses. As with everything in project management, it will be only as good as the context and its implementation, so keep that in mind before trying to apply it everywhere. But why use PERT? Why not just stick with the usual off the top of your head guess plus some slack time? After all, if you're watching this video, this probably isn't the first time you have had to produce estimates for your project, and everybody seemed happy with the way things were, right? So why fixing something that isn't broken? Well, it's always a good question to weigh the pros and cons of any change to our ways of working, so let's look at what PERT has to offer. The key thing is that estimating is always an attempt to predict the future, no matter how sophisticated the process. PERT embraces uncertainty and makes it an explicit part of the calculation. We integrate the underlying lack of clarity that all humans have when estimating tasks by providing guardrails against the natural biases that come with an individual's experience, knowledge, and feelings about the task before them. Another great advantage of PERT is that we can use it to estimate effort, cost, and duration in any project, regardless of the life cycle behind it, meaning that it also works in an Agile context. Remember, Agile does not mean lack of estimates, but rather flexibility to change, and PERT is compatible with that. Now, for PERT to really live up to its potential, we need to address something important about providing estimates to stakeholders and leadership. This might sound bizarre to those used to be lied to. Reporting ranges is actually more professional than reporting single values. Now, you don't need to agree with me on this, but at least keep this in mind. As a project manager, you have to be very careful when stating data, especially estimates. The task will be ready in 20 days. Unless you know all the moving parts and you have them all under your control, you are risking your word, and worse, the team's, by being so straightforward with it. I'm not saying you have to be cryptic or vague about information you and the team have worked hardly to put together, but my suggestion is, if strict timelines are not a critical part of your project, do not bring unnecessary attention to them. If possible, go with a more flexible statement, one still based on data, but also aware of the fact that we can only do so much to know all the moving parts of a project, and we definitely cannot control everything. PERT will allow you to state ranges of time or cost that will be closer to reality than a fixed number. The task could take between 16 and 24 days, communicates inherent risk, but gives enough certainty to plan and evaluate consciously what would mean a worst-case scenario and a best-case scenario. And that is the professionally mature conversation you want to bring about your project. An assertive project manager will know that being so specific about estimates is likely to be today's bread, tomorrow's hunger. We'll talk more about this towards the end of the video, but managing a project is also building trust with stakeholders, and being open about uncertainty is one way of nurturing it. So how does PERT work? First, we have to touch on the concept of a normal distribution. If you're unfamiliar with it, you just need to know that it can be visualized as the chart on the screen. The x-axis represents all the possible outcomes of a given event. For example, if you roll the die, you will have the numbers from 1 to 6 on your x-axis, whereas the y-axis represents the likelihood of set outcomes. The higher the curve, the more likely that outcome is to occur. So this chart represents the probability of an event taking a value between the range of outcomes described by the left and right ends. And the normal distribution implies that the closer an outcome is to the center, the higher its probability. If we had two potential outcomes, A and B, we could say that B is more likely than A. That does not make outcome A impossible, but just less probable than B. PERT is based on a slightly different concept, but for it to be fully realized, it is assumed that most events, or activities in the case of projects, will end up behaving like a normal distribution. Let's look at an example. We need to work with the developers to estimate how long it will take to add validation to an input field. After a brief conversation, we have obtained some values to consider. In a normal distribution, we could say that less than 3 hours would fall on the leftmost side of the curve. It's close to optimal, but unlikely. On the contrary, more than 9 hours would be on the rightmost side. It's a pessimistic estimate, but also unlikely. Therefore, anything between 3 and 9 hours will be more likely. Let's recap the 3 ideas we just laid. To be able to estimate with PERT, we need to determine 3 things. The optimistic estimate: if everything goes right, how much effort could it take? The most likely estimate: based on the developer's best judgment and considering previous experience, if any, how much effort could it take? And the pessimistic estimate: if everything goes wrong, how much effort could it take? Remember that PERT works for time and cost, as well as for any type of project. Here, we're just using effort and a software-related project as an example. The 3 key data points translate as is to other contexts, and it will always boil down to talking to the people responsible for providing estimates. So be realistic, keep it reasonable. The pessimistic scenario does not need to involve catastrophic events, and the optimistic scenario does not imply perfection at every single step. Think about risks and opportunities when working with PERT. If a risk is unrealistic, it does not need to be considered when estimating. We can now jump into the formula. O stands for the optimistic estimate, M is for the most likely estimate, and P is for the pessimistic estimate. Hence, to calculate PERT's estimate, we have to sum O plus 4 times M plus P and divide all by 6. We are multiplying the most likely estimate by 4 to add more weight to it, so most likely translates to the final result. And because we have done that, we now have 6 values as opposed to just 3, so we need to divide everything by 6 to get a properly weighted average. Going back to our example, the conversation with the developer could go like this. We have the task before us, adding validation to an input field, and we need to know the expected effort considering PERT's 3 key data points. As the developer is now comfortable thinking in terms of pessimistic, optimistic, and most likely scenarios, we could determine that the best case would take 2 hours, the worst case 8, and the most likely 3 hours. If we plug that into our formula, we would get 2 plus 4 times 3, which is the most likely estimate, plus 8, and we will always divide it by 6. That gives us an estimate of 3.66 hours. And now we can use that to continue with our planning. Now, in a real project, you will have to estimate several tasks. The table below shows some examples with their own 3 data points and results. Notice how PERT estimates are closer to the most likely scenarios than to the optimistic and pessimistic ones. That makes perfect sense, as we are giving 4 times the weight to the most likely value. But what happens when you need to roll all these up and provide an estimate for a set of tasks or even an entire project? Well, remember when I said that a normal distribution behaves like this? Most likely events will always be in the center of potential sorted outcomes, and less likely ones will fall on the left and right extremes. We now have to talk about the beta distribution. You see, many real-life events, especially tasks in projects, behave like a beta distribution. The main difference with the normal distribution is that likelihood of outcomes is skewed towards one side or even both sides, meaning that sometimes optimistic events could be more likely than pessimistic ones, and vice versa. The classic bell shape of the normal distribution looks different since the probability spreads out differently. This is not a problem, but know that the basics of PERT consider this. Calculating PERT is approximating to the mean of the beta distribution, comparable to calculating the highest point of the curve, where the most likely outcomes have clustered, whatever that peak happens to be. In our example, we have determined that mean to be close to 3.66 hours. So why bother talking about normal and beta distributions in the first place? Well, it's always useful to know the rationale behind the techniques we use on a daily basis. To me, that adds more flexibility to their use and expands our toolkit beyond the basics. But there is another reason that supports the next steps of working with PERT. Meet the central limit theorem. In very simple terms, we can interpret it as multiple somewhat independent events, even with different types of distributions, will tend to a normal distribution when added together if the sample is large enough. And that is the key part. the sum of events that follow different distributions, such as beta distributions, eventually behaves close to a normal distribution. That allows us to use techniques and known properties meaningful to a normal distribution when planning in the context of projects with PERT. Remember, we are estimating to the best of our ability as we cannot predict the future. We could spend hours working on techniques applicable to the specific distribution that the task before us follows. But this is futile for Agile, and it is simply too expensive even for predictive life cycles. So assuming that groups of tasks estimated with PERT follow a normal distribution is acceptable. Now, we can simply get back to assuming the task follows a normal distribution and focus on the next step, which is calculating deviations. A normal distribution lets us calculate the value of sigma, which is one standard deviation. If we calculate one sigma to the left and to the right of PERT, we will essentially be defining the ends for the range we intend to determine and, if you see the opportunity, communicate to stakeholders. We also know, as a property of the normal distribution, that one sigma to each side of the mean represents about 68% of the entire set of probabilities. This is, if we calculate the range with just one sigma, we will be estimating with almost 70% accuracy. This is huge and a solid step forward from just guessing estimates. Calculating 2 sigmas on each side would mean covering about 95% of all possibilities. This makes our estimations almost accurate every single time. And if we went for 3 sigmas, we will be covering almost 100% of scenarios. Can you imagine estimating with 100% of accuracy? Well, that is just not practical. See, each sigma pushes the range of the estimate further, to the point where it becomes meaningless. The more sigmas we add to PERT, the closer the range will go from 0 to infinite. So we could say that every task will take between 0 and infinite effort, but that will help nobody. Hence, in most, if not all cases, a single sigma will provide enough certainty. Let's see why. A standard deviation is equal to sigma. From now on, we will refer to it as such. The formula to approximate the standard deviation of a single task with PERT is P minus O, divided by 6. That is, the pessimistic estimate minus the optimistic, over 6. In our example, where P equals 8 hours and O equals 2, the standard deviation is 1 hour. So now we can state that adding validation to an input field is expected to take between 2.66 and 4.66 hours, with 70% confidence. In the corporate world, such level of transparency is very valued. It conveys acceptable levels of certainty while leaving room for unforeseen events and risk management. If we go back to our extended table with some other activities, we can see the standard deviation calculated for each one. The range column states how the estimations could vary and provides a better idea of what to expect from the overall project. Now, as project managers, we must be able to provide totals. How long will the entire project take? How much will it cost? We have to take the last step to maximize PERT's value. First, we can simply sum the individual PERT estimates of linear activities to get a rough value. Keep in mind that if activities overlap, summing their individual estimates may not be accurate. This is a good moment to consider using a software to help you calculate true dependencies. In this example, we can safely assume that all activities will take place one after the other. Hence, it makes sense to sum their estimates. However, we can't do the same with the standard deviations. That is not statistically correct. Bear with me for this final step. Another useful concept in probability distributions is variance, which also tells us the dispersion from the center point, but in a way that we can use to calculate the overall deviation. We will calculate one for each standard deviation by using the following formula. Individual variance equals individual standard deviation to the power of 2. And once we have done that, we can proceed to calculate the standard deviation of the entire set of tasks. This is done by summing all variances and taking the square root of the total. With that, we get that the set of tasks have a total estimate of 203 with a standard deviation of 11. Or, in other words, the full set of tasks will take between 191 and 215. That's 1 sigma to the left and 1 sigma to the right of the sum of all PERT estimates. Finally, let's touch on how to actually implement PERT. Once again, it is an estimation tool that improves over empirical approaches. As with everything in project management, you need to sell the concept. Get buy-in from stakeholders. Not all of them will want or need to understand the math behind it, and really it is not necessary for them to do so. but let them know how working with ranges and investing a little more on estimates will pay off with higher certainty and fewer broken promises. The most important rule in project management is to tailor your tools to the context before you. With PERT, that means adjusting the depth of your estimation discussions. You can spend a lot of time discussing all potential outcomes of every task's estimate, and that may be necessary for predictive projects, also known as waterfall. But in more agile-oriented ones, a brief conversation may be all it takes to improve confidence. When you have to work on an estimate, consider this. For every task or group of tasks, sit down with the person responsible to provide estimates. Developers, analysts, testers, engineers, users, managers, or whoever is closest to the task, and ask them, based on what you know about this task, what could go wrong? What could go right? Then ask, if everything went wrong, realistically speaking, what would your estimate be? And then, what would happen if everything went right? Finally, what's the most likely scenario in your view? I strongly recommend having this conversation in person or by call, especially the first time implementing this tool, as people used to just providing close fixed estimates will find odd that they now need to answer more questions than before. It is likely that if they are not bought into the idea, they will brush off your request as excessive and simply skip to the single point estimate. That is why it is key to spread the word on why PERT is relevant to the project, and that is part of your work as project manager. Working with PERT not only improves estimates, but protects everyone's credibility. Secondly, it is a good practice to ask these questions in order. You don't want to talk about the most likely scenario before talking about the worst case and best case. The two extremes will set the proper tone for your counterpart to calibrate and be more thoughtful when estimating. And that is all. Thank you very much for your time watching this video. I hope it proves useful to you. Let me know in the comments below if you have any questions or if you have a different approach to estimating. I'd love to know what you think. See you in the next video.